So in this class, we are going to discuss about page replacement. Already we have discussed the basic concepts of page replacement. Let us study in detail. Okay, first, let us divide the word page replacement into two parts. One is page, another one is replacement. Already you know about what you mean by page. Page means what? A partition of main memory. Okay, in paging memory management system, as well as in segmented memory management system, virtual memory, we have discussed this key term called the page. Memory is divided into various partitions, and so as the user program also divided into various partitions of equal size, means paging, of based on segment, means a segmentation. Okay, that is what we are referring as page. To say it simply, it is a partition of main memory. Replacement means what? We are going to replace the existing page with some new page. So what is the situation and how this page replacement is working, we will discuss in detail. Okay. First, what is the need of replacing an existing page? See, listen carefully. If there is no free frame, that means what? In main memory, if there is no free frame, we find one that is not currently being used and free it. Okay. Consider one process P1. P1 is having three partitions A, B, and C. Okay. Now in main memory we are having A and B. Okay, main memory we are having A and B. And some other programs are also available in main memory of different process. Okay. Now main memory is full. So here also we are having some process. Here also we are having some process. Here also we are having some process. So main memory is full. Now process P1 wants to load C to execute particular block. Okay, wants to load or wants to have the block C in the main memory in order to continue its execution. Now C is not available in main memory. That is what here we are telling. If no frame is free in main memory, there is no free frame. What we are going to do? We find one that is not currently being used. So A and B is in use by process P1. There may be some other process which may not be in use. Okay, if it is in use, we cannot change the process. If it is not in use, then we can replace the particular page. Okay, that is not currently being used and free. Suppose if this page is not currently in use, then we will free this. How we will free this? We will move this particular page into secondary storage. Okay, so from main memory, we will store or we will transfer the particular block or particular frame or page into secondary storage. This is what we are referring as swap out. Okay, we are replacing or we are transferring a particular page from main memory to secondary memory. And now this frame becomes free, so we can load C into main memory. This is swap in. Okay. How this process will take place? Okay, step by step procedure we will see. Find the location of the desired page on the disk. What does it mean? Find the location of the C. Location of desired page means what? Here we need C. So find the location of the block C on the secondary storage. Okay, if C is not in secondary storage, then there is no use at all. Okay, we cannot continue our process. So first find the location of C in the secondary storage, first step. Second step, find the free frame. Here, as I told just now, find a particular free frame or find a frame that is not in use. Okay. If there is a free frame, then directly you can transfer the block C into main memory. If there is free frame, no problem at all. Okay, we can just transfer from secondary storage to main memory. If there is no free frame, what we have to do? Use a page replacement algorithm to select a victim frame. So I told here it is free, but we don't know what is free. So what we are doing? We are going to use one page replacement algorithm. Based on that algorithm, we have to select a particular frame that is to be free. Okay, page replacement algorithm. Here we are referring it as victim frame. Which frame we are going to free based on some condition. That condition will be referred by the page replacement algorithm. Okay. Now, after selecting a particular frame that is referred as victim frame, write the victim frame onto the disk as I told. Okay. Now that particular block will go to secondary storage. Change the page and the frame tables accordingly. Of course, page table and its entry for the corresponding frame will be changed accordingly. Now read the desired page into the newly freed frame. Okay, now we are copying the block from C into main memory. Change the page and frame tables accordingly. Continue the user process from where the page diagrammatic representation. Okay. What is step 1? Page out the victim page. So I have selected this is the frame to be freed. So I am performing swap out to secondary storage. Then what is step 2? Change the corresponding victim frame as invalid. Okay, now it becomes invalid because I have already shifted to the secondary storage. Now third step, copy the desired page into the particular place, that is swap in or page in. Now change the page table accordingly as valid bit. Now that will be filled with the valid. Now this becomes valid. Okay, swap out and swap in. First we have to swap out, then only we'll get to the free frame. Then only you can copy the required page onto the main memory. Okay, first swap out or page out, then change the page table accordingly, then swap in. After that also change the page tables accordingly. Okay. So in order to discuss the various page replacement algorithm, we have to discuss with some examples. Okay. So in order to define that example, we have to follow some constraints or some conditions. What are the conditions? Okay, first one, we evaluate an algorithm. Okay, we are going to discuss page replacement algorithm. To evaluate a particular algorithm by running it on a particular string of memory references. So we are going to give a series of memory references. Using that references only, we are going to implement the page replacement algorithm. Okay. So in order to compute the number of page fault, already we have discussed what is a page fault. Okay. If the required page is not available in the main memory, then page fault occurs. Okay. The string of reference is called, memory reference is called a reference string. We can generate reference strings artificially. Okay, on your own, you can generate the reference string by having two important assumptions. What are the assumptions? First one, for a given page size, we need to consider only the page number rather than entire address. For example, if I have one memory address like this 103 and the page size is 100, okay, now what I will consider is page number only I will consider. Here page number is 1 and offset is 3. Correct? Already we have discussed this. Okay, so page number is 1, offset is 3. So 1 into the page number into page size plus offset. What is page number? 1 into page size 100 plus 3 will give you the physical address. Correct? So based on that, here I am going to consider only page number and not offset. Suppose if the page reference is 513, I will consider only the page number 5 and I will not consider the offset 13. Okay, if it is 793, then I will consider only the page number as a 7. So here My reference is here it is 1, here it is 5, and here it is 7. Okay, first condition. Second condition, if we have a reference to a page P, then any reference to page P that immediately follow will never cause a page fault. Okay, now consider my reference is page number 5, which is not in main memory. Okay, consider this as free frame. Okay, I want to execute page number 5, which is not available in main memory. So one page fault will occur. Then I will copy the desired page into main memory. So here I will copy the page number 5. Okay. Now next reference is 512. What is page number 5? Which is already available in main memory. So page fault will not occur. Even though the memory address is different, 512, already the entire page number is available in particular main memory. So there will not be any page fault. Okay. Next reference, for example, if it is 575, what is page number 5, which is already available in main memory, so page fault will not occur. Okay, so if a particular page number is already available in the page frame, in the main memory, any number of references to the particular page will not result in a page fault. So when page fault will occur? Only if it is not available in main memory.